So let's see our registrant joining. Give it a few more moments, guys, so we let everybody join in before we start. We're here today, Bob, talking about our EX wall chart, right?
Absolutely, yeah.
Okay,
Yeah.
good. And we will start in a few moments. Let's take this moment while we wait for everybody to mention that you guys can intervene using the question and answer box. There should be somewhere. Okay, here we go. And or eventually we will answer some question at the end of the webinar. So Bob, let's what time it is? 17:01. Let's start. Here it is our webinar. Great. Understanding wall chart, fundamental of EX.
You see my screen?
Yeah, we see the screen. Just next slide and let's begin.
Okay.
So, okay, this is us, Bob and Paolo. For those of you who don't know Bob, he's our guest speaker for today. He's done several webinars for us. He has over, I used to say over 30 years. He's still 30 or is now 40? A lot of years of experience in the EX world.
Yeah,
It's
coming up.
EX Strato. Sorry, Bob, go ahead.
Yeah, 39 years.
39. You see, so we're almost there.
Almost.
EX Strato, Strato ICEX PC scheme, inspector. What else, Bob? You are an STP committee.
That's enough.
Yeah,
I am actually one other thing that I got railroaded a little bit into. I'm a chairman of an ASTM committee for marine engineering. So working a lot in the alternative fuel vessel, the LNG, hydrogen area in which a lot of now we're seeing a lot of hazardous locations showing up in the transportation, the marine business. So
absolutely, very interesting. Bob, we will talk about this. This is also one of our verticals, so we need to discuss how we can work together in that.
Yeah. Actually,
we need to have ideas on what the market is. But let's go to our webinar because this is we're not doing business here today. So GMI, for those guys who don't know GMI, I will take 3 minutes to introduce it. We are an international company designing, engineering, manufacturing a complete range of IS and SIL certified interfaces, which are used in automation packages such as CSD, fire and gas, DCS, which are used in several sectors such as oil and gas, pharmaceutical, fertilizer, mining, as well as in transportation. We do a lot in marine business. We supply a lot to ships in Korea and China. We have lots of years of experience, and we are very proud to manufacture our product in our facility, in a state-of-the-art facility near Milan, Italy. On the other hand, we are global players present in all the continents. Next, Bob. Well, I guess we skip online, but that means we have subsidiaries all over the world. So we are. No, it's okay. It means that I don't remember how this is run. It's been 3 months. So because we make safety products, our products are designed to provide safety and availability of the plant. Basically, every single wire, so every single sensor or control valve or transmitter or whatever goes through one of our elements. So this element, outcome is either they stop the plant from operating or they can create a danger to the plant. So we take a lot of effort in making the best product that we can manufacture today, because we believe in safety, and we believe in the safety not only of the product but also of the plant and the people and our environment. Next, Bob.
No, come on now.
Come on. Nope. Oops. Okay.
Nope.
It's okay.
There we go.
So these are the products we manufacture. So we have IS barrier, SIL3 certified, SIL2 certified, safety relays with and without line monitoring, isolator, also SIL certified. We have power supply, which are also designed for hazardous location and for SIL certification. We have multiplexer, temperature digital, art multiplexer. We have surge protection. We have termination panel. We have a division that runs courses as well as webinars and seminars like we are doing today in the functional safety, EX, and today also cybersecurity domain. Let me see, next slide, Bob. You see this slide was supposed to be earlier. So where we are globally. So we have different offices and as well as distributor. And we run many courses as well as we have a lot of PTR. So next, some of our customers, basically we supply all the system vendors, many APCs, many OEM. We're very proud to have a lot of OEM across the world, many in the Houston area, many in the US. Because of course, you know, oil and gas manufacturing company are out there, drill rig company, skid manufacturers, and, you know, a lot of those, Schlumberger, Halliburton, NOVs, FMC. Oh, and we are on the vendor list of most of the oil and gas and petrochemical company around the world. I believe that's it. Now it's our bit. I will be here. I will listen in, and we'll. If you guys want to type any question in the question answer box, I'll be able to look at it, and let's see when we can reply to them. Okay, Bob, go ahead.
All right. Well, thank you, Paulo, and thank you everybody for attending. This was one we haven't done this one in a while. We did it probably about a year or so ago, I guess, and we had a lot of good responses. We were kind of just trying to think about, you know, various topics, and it made me think about the fact that a lot of places I walk into, you'll see EX wall charts, and I just remember distinctly going into some folks and just asking them questions, because we teach a lot of this under either the COMPEX scheme or the IEC EX Certificate of Personnel Competency scheme, and we use wall charts, and we talk about them and how to use them. And, you know, it was interesting because I'd ask some folks, I said, hey, what, you know, do you ever use, oh yeah, this is great, wonderful. Can you explain this to me? And, you know, kind of put them on the spot a little bit, and they'd kind of, no, that's, you know, if I have a question, I call you. I was like, yeah, but you should understand this, right? And wall charts are fantastic. They're available from different manufacturers, use certification bodies. They're everywhere. GMI makes a really nice one. And anybody who would like one at the end of this webinar, certainly just drop us a note. We'll make sure we get you copies of them as well. But they're all slightly different, but more or less they have a lot of the similar information on them. And there's a lot of information on there that sometimes can answer some of these questions that we might have when we're doing our design, or we're just trying to understand a little bit more about EX. So wall charts are fantastic, but it's also important to understand, well, what is on here? You know, what am I looking at, so to speak? So we want to try to take the GMI wall chart and kind of break it down into various topics and kind of explain, if you will, what these various topics mean, and hopefully make it a much more effective means or a tool that you can use, you know, hang up in your cubicle or keep with you or do what have you, to use it as a tool, because they are handy. They're very helpful, and I use them all the time. So this is the example of the GMI EX wall chart. So it's understanding hazardous locations, right? And you'll see it's broken down into various topics. And again, not everybody's wall chart is going to be identical. They're all going to be slightly different. Some manufacturers will emphasize certain things. Certification bodies will emphasize other things. They may reference some other information. But this is pretty much, you know, a pretty good example of what you typically would find on a typical EX wall chart. A little bit about area classification, a little bit about gas and dust groups, temperature classes, protection degrees, IP codes or NEMA ratings. The marking strings, that's usually always a big thing, and that's where these charts really do come in handy when we start looking at marking strings to kind of explain really, if we're taking a look at a product, we want to understand, is it suitable for this particular environment? That's where we get this information. GMI also has an IS verification example, a little bit about certifications worldwide, and then the types of protection that you would typically find as protection concepts and the relevant standards. And then there's also some information on SIL ratings for ATEX. So let's kind of break it down. Let's talk about area classification first. So area classification that's referenced within this chart is referencing two different major standards, if you will. The 60079-10-1 that deals with gases and vapors, and the 10-2 that deals with dust. Now, depending on where you are in the world, you may find other area classification documents that are widely used. The ones that are probably the most commonly referenced outside of the IEC standards one is called the Energy Institute IP15. That's not to be confused with ingress protection that used to be known as the Institute of Petroleum, and now they've changed their name to Energy Institute. The IP15 is kind of the gold standard for area classification. It's a very involved document. The IEC standards, if you will, have based a lot of their relevant information that has come straight out of the Energy Institute IP50 document. So that's an incredible document to understand. We teach that course around that area classification document, and it's very much involved. Within the United States, and you will find this as the U.S. goes, you see, influence from U.S. oil and gas companies around the world. You'll see things like API, American Petroleum Institute recommended practices, 500 and 505, or maybe an NFPA, National Fire Protection Agency 497 document. These are also area classifications, or area classification is incorporated into these documents as well. So unlike the IEC standard or the Energy Institute standard, they're very prescriptive, or where they may say, we'll have a picture of, say, a tank, and we'll basically say within a certain distance of this tank, depending if the gas is above or below its flash point or whatever is inside the tank, we may have a distance that says, hey, this is going to be considered to be a zone 1, this is considered to be zone 0, this is considered to be zone 2, and that's how we typically do an awful lot of area classification. It's kind of cut and paste, where the Energy Institute document, as well as the IEC standards, are now actually doing a lot more calculations and taking into account things like ventilation, and is it indoors, is it outdoors, the density of the gas. All of these things are taken into account. We start doing calculations to come up with what our areas are located. So when we look at our wall chart, we talk about protection level. Protection level is very high. That's 2 independent means of protection, or 1 protection allowing 2 independent faults. And we can use that in an area in which an explosive atmosphere is frequently or for long periods or continuously present. That's typically what we would consider to be a zone 0 environment for gases, or a zone 20 for dust. We would indicate that under the ATEX marking as a Roman numeral 2, just working our way across that one line, equipment category 1G, or under the IEC EX, we would also say that is a group 2, and then a GA. So an intrinsically safe barrier that's manufactured by GMI will actually fall within this category. It's a typical barriers you're going to find are going to be suitable for providing protection downstream into a zone 20, or excuse me, zone 0. And they will have protection of GA, if you will, downstream. That doesn't tell you where it can be installed, but that will tell you the information as to what protection it can provide. The one below that is a high level of protection. This only allows a single fault. Now, this is where we have a flammable gas atmosphere present during normal operation or dust, and we consider this to be a zone 1 area. And in this case, equipment category under the ATEX directive is considered to be a 2G environment, or under the IEC EX equipment protection levels, we call this a GB environment, or GB suitability. And then finally, a normal, safe during normal operation. This is where we typically have a hazardous area for short periods of time. For gases and dust, it's going to be either zone 20, or excuse me, zone 2 or zone 22. Equipment category is going to be 3G or 3D. Under the ATEX, or excuse me, IEC EX EPL, it's going to be GC or G or DC. Now, I think on the next chart, I've kind of actually referenced this same information. You'll also see equipment that is suitable for mining applications under the ATEX directive. That'll be referenced as M1 or M2. And again, for surface industries, it's going to be 1, 2, or 3 under categories. It's going to have a G or D, gas or dust hazards. And then per the IECEX, we have 3 equipment groups. And actually G for gas or D for dust. And actually that's a little bit incorrect. It's actually GA, GB, or GC. So protection levels, again, very high, 2 fault tolerant, zone 0. A high is a single fault tolerant, zone 1. Normal is a non-fault tolerant, zone 2 type equipment. So the thing to remember from this is that as we look across and we see under the ATEX equipment category 1G as an example, under ATEX, that means the exact same thing as GA under the IECEX marking scheme. As a matter of fact, now for marking of products, the ATEX directive now requires manufacturers to incorporate the EPL into their marking string. So when we look further at our wall chart, you'll actually see what I'm talking about. Now, outside of the international world, when we're for the most part, we also have what are called division applications, where it's division 1 or division 2, as opposed to 3 zones. In the international world, we typically have 3 zones. In the US installations, we have 2 divisions. So division 1 is an area in which it exists under normal operation. Division 2 exists under abnormal operation. If you look at the chart over there on the right-hand side, you'll see for the gas, a class 1 that deals with gases and vapors. Class 2 deals with dust. Class 3 deals with fibers or flyings. We subdivide either division 1 or division 2. Notice that division 1 basically breaks down into the same as either zone 0 or zone 1. Division 2 and zone 2 basically are pretty much the same. It's not identical, but it's very similar. So you could have in the international world where we could say that's classified as a zone 0 environment. In the US, we would say that might be a division 1 environment. In the international world, we could say that's a zone 1 environment. We still might say that's a division 1 environment. If it's a zone 2 environment in the international world, we typically would say that's a division 2 environment in the US installations. So
Okay.
our first poll question.
First poll question, tough one though. What would be the definition of zone 1? Oh, have I got the right one up here?
Yeah, think so.
Yeah,
Zone
no,
1 hazardous.
the poll I got is a different one. It's about marking strings.
Oh, you got the wrong one.
Yeah, but you know what it is? It's not put in the right location. Okay, this one.
Yeah. Well, that's a tough one right there.
No sondage.
I tell you what.
Guys, let's start. You read what you say there, and I will try to launch it because I'm having a problem.
Well, since some of you have actually started to answer this one, let me explain what that marking string actually does mean, because it can be somewhat a
I cannot launch it. I don't know why. Did you see the
no
poll up
worries.
there?
No worries. Let's see what you guys get. So we haven't talked about protection concepts, but EXDB is now flame-proof. It used to be legacy. It was known as EXD. It is now changed, and now D is now DB. And then we see IA in brackets. That means that we have, in effect, a flame-proof enclosure that incorporates what we would call an associated apparatus on the inside of a flame-proof enclosure or intrinsically safe barrier of some sort. It is suitable for gas groups 2C to be installed into a 2C environment. It has a temperature code of T6. There we go. We got a definition. Oh, well.
Now it works, right? Now this is the right one, correct?
Oh, okay. There we go.
I'm sorry. It seemed like a few months I haven't. It was positioned in the wrong place inside the box.
Yeah, no worries.
Find the right,
Well, you'll see that poll question later on. So the marking string, and
yeah, marking string is a tough one. This is easier. This is an
It's
easy
a
one.
little bit easier.
What would be the definition? I guess, guys, you can now have opportunity to answer. Bob has been explaining what the questions are. And zone 1, 6979-10. So first, I guess the first question that I would have is, what is 6979-10-1? You know what I mean? Are we talking about a zone, I guess? So it's international standard.
That's our area classification standard for gases and vapors.
Perfect. So place where a gas and vapor is present frequently or continuously. Place where a gas and vapor is present occasionally. Place where a gas and vapor is not present, well, zone 1, hazardous environment. Can I give it away or?
Yeah, absolutely. Go ahead and take a shot.
My pick would be A.
Okay.
Let's see what our friends have answered. Termine sondaggio condividi. We have mixed answers, guys.
Okay. So A, place where gas, vapor, hazardous atmosphere is present frequently or continuously, is not the correct answer. It is actually, that's a definition of zone 0.
Are you right? It is zone 0. Correct.
Zone 0, it's a continuous hazard. So an example of that might be inside of a tank in which it's storing a liquid that has vapors above its flash point. So that area in between the liquid and the inside of the tank where there's the vapors, that is a continuous hazard. So we would call that a zone 0.
You are 100% right. Or a division 1.
Or division 1, that is correct. So it's not A. The reason why it's not D is a place where dust hazards, atmosphere, occur present occasionally during normal operation. Well, this isn't a dust hazard. We're talking zone 1, not zone 21. Zone 21 would be a dust hazard. Zone 1 is a gas hazard. And 60079-10-1 is for gas hazards. 10-2 is for dust hazards. So it's not D. So your choices are B or C. So a B is place where a gas, vapor, or atmosphere is present occasionally during normal operation, or C, a place where a gas, vapor, hazardous atmosphere is not present occasionally during normal operation, but occurs infrequently. So between the two of those, which one would you think at this point, Paulo, would be the correct answer?
Well, it would be B because C, I would think it would be placing as an answer. It's not present occasion. It would be division 2, zone 2, no?
Zone 2, that's right. So C would be a zone 2, division 2. B would be a zone 1 hazardous environment. So there you go.
You know, I fare, you know, like most of the, we have 54% got it right. So guys, you did better than I did. All right.
No worries, no worries. This is all for learning, right?
And I will try to get the right poll for that because there will be more questions, guys, coming up. I will try to get the right one now.
So now we also, one of the things besides just after understanding the zone in which the flammable atmosphere is located, and zone basically is the frequency and duration of a flammable gas or dust atmosphere. So if it's there continuously, we call that a zone 0. Again, just like our last poll question. But it doesn't tell us the properties of the particular gases or vapors. So we also need to understand the properties of particular gases and vapors when we're selecting EX equipment. And we do that based upon not just the suitability of the zone, but also based upon the gas group in which we're wanting to place this piece of equipment. And we do that based upon a couple factors. Number one, the minimum ignition energy, and this really applies to intrinsic safety, the explosive pressures, or the MESG, and the explosive range, the lower explosive limit and the upper explosive limit. So these are some of the factors that we need to take into account. So on the international side, we more or less have 3 gas groups that we follow. We call them either 2A, 2B, or 2C. 2C gases are the most onerous or the most dangerous. They're comprised of hydrogen and acetylene. There's another gas in there as well. I can't remember the name of the gas off the top of my head, but that's a 2C gas. But those are pretty much hydrogen applications is a 2C gas. This is one of the things that when we're talking about using hydrogen as a fuel, we have to be really considerate of the fact that hydrogen is a very, very volatile gas. Doesn't take a lot of energy to ignite. It has a very wide explosive range, and the volatility of hydrogen itself, along with acetylene, is also extremely volatile. So using hydrogen as a fuel of the future is got a lot of issues. The US, we follow groups A, B, C, and D. So where you see over on the left-hand column, you see gas class 1, group D, group C, group B, and group A. It's just flipped over in the international world where we have, instead of group D, we have group 2A, which is the main gas is considered to be propane. Group 2B is ethylene. Group 2C is considered to be hydrogen, with the exception of, was that hydrogen, carbon disulfide. And then 2C is also acetylene as well. And then we also have our dust hazards, groups G, F, E, F, and G. The most onerous dusts are metal dust, conductive dust. We have to be very, very careful when we have combustible dust that are metallic, especially with electrical equipment, because they can conduct themselves. If they land on anything that's energized, then they can provide a path to short out and potentially create an ignition source based upon an arc. The important thing to note with regards to this is that if a product is suitable for groups 2C, then that product will also be suitable for a group 2B or a 2A environment. So if we select a product that's good for 2C, it will also default as good for groups 2B and 2A, assuming some of the other parameters are also met, okay? And the other thing to note, and I didn't mention this, but with regards to zones, the equipment, if a piece of equipment is suitable for a zone 0 environment, it will always be suitable for the equivalent zone 1 or zone 2 environment. If it's only good for zone 1, it'll be good for zone, or if it's marked for zone 1, it'll be suitable for zone 1 and zone 2. If it's only marked suitable for zone 2, it's only suitable to be used in a zone 2 environment. Now, ingress protection codes. These are actually not just applied to EX equipment, but will apply to general purpose electrical equipment. And this is an IEC 60529 standard. And this is based upon 2 digits that they put together. And as the digits increase in numbers, if you will find that it's actually a higher level of protection in general. So if I have a piece of equipment that's IP54, generally that's dust protected. It's protected against splashing jets of water. That is going to be a better product or more environmentally suitable product than maybe a product that is IP42. There is one exception to these IP codes that you need to be aware of. A lot of products you might find IP66, or you might even see a project in which they're requiring an IP66 rating, and you might assume that IP67 is better. In reality, IP66 is a more onerous or more difficult test to achieve because based upon the powerful jets of water that are being shot at a particular piece of equipment, it's actually more difficult to achieve an IP66 than it is an IP67. So sometimes you'll actually see manufacturers will mark 2 different IP codes on their pieces of equipment. They'll be marked IP66 and 67 just to eliminate that potential confusion. In the US, we have North American NEMA ratings. NEMA ratings are similar to IP codes, but they're not exactly the same. So generally speaking, they also take into account the corrosion resistance of the particular piece of equipment itself. So for example, an IP or a NEMA 4 enclosure might be very similar to, say, an IP65 enclosure from ingress for dust and water, but it also, excuse me, will be a corrosion resistant material, IP4X, not IP, NEMA 4X. So NEMA 4X will actually be maybe a corrosion resistant, like a stainless steel enclosure, or maybe a glass reinforced polyester enclosure. Now, temperature codes, this is another important thing that you'll see on this wall chart. Excuse me, all gases and vapors will have what is called ignition temperature associated with their product or the properties of the particular gas. And you'll see in the international world, we have 6 T codes, T1 through T6, and they correspond to the numbers on the left-hand side, which is the maximum relevant surface temperature of that particular product. And it ranges from a low of 85 degrees C to a high of 450 degrees C. What you want to take away from this chart is that, in effect, if I have a product that is rated T6, that means that that product under its normal ambient will never exceed 85 degrees C. And so therefore, this product will be suitable for all gas groups based upon its ignition temperature. So a product that is marked T6 will be suitable for a T5 environment, a T4 environment, a T3 environment, and so forth and so on. On the other hand, if I have a very hot piece of equipment, maybe a transformer or maybe a light fitting that is rated at T1, that means that the relevant surface temperature will never exceed 450 degrees C. But if I want to put that in an environment in which the gas has an ignition temperature of, say, 200 degrees C, the product will get too hot and it potentially will ignite that flammable gas, and we don't want to see that. So a T1 product is only suitable for a T1 environment. A T6 product is suitable for all environments. And what you see on the right-hand side is that you'll see some of the ignition temperatures that you will typically find of some of the real common gases and vapors. Notice hydrogen. One of the positive things about hydrogen, it has a very, very high ignition temperature of 560 degrees C. So hydrogen is a T1 gas, if you will. Methane for use in LNG has an ignition temperature of 595 degrees C. But notice some of the other gases and vapors, such as heptane or ethyl ester or ethyl ester, ethyl ether, has an ignition temperature of only 175 degrees C, or even something like carbon disulfide of only 90 degrees C. So there are gases and vapors that have very, very low ignition temperatures, and we really have to take that into account when we're selecting EX equipment for those environments based upon the temperature codes.
Okay, so here's another poll. This is a very easy one. You basically just show the chart. What will be the T code for a product that has a maximum relevant surface temperature under normal or full condition of 125 degrees C? From T2 to T6, you can pick one. Now, Bob, since our guests here are, guessing, we have a few questions regarding the IP rating.
Yeah.
Maybe you can go into it. So, for example, what about IP66 versus IP68?
Yeah, so IP68, IP68 is actually one of the tests as part of the 60529 standard that is not necessarily uniform for every product, meaning that as a manufacturer, I can choose. So IP68 is basically not temporary immersion, but basically full immersion in an environment in which it's going to be surrounded by water. But it could be 1 meter for 5 hours. It could be 10 meters for a week. So the IP68 test can be different depending on what they've actually tested it to, where all of the other IP tests are pretty much uniform. Now, that being said, generally speaking, if somebody is requiring IP66 and you say, hey, I've got IP68, I would be very careful on that one because again, we don't know if a product, if it's only an IP68 for say 1 meter for a couple hours, then that may or may not pass the hose down jet hose down test that you have to undergo under the IP66. So
So it depends on really on your application.
it does,
Like
and
if you want to
I would,
submerge it, or you want to be
yeah. For example, like I said, you'll see some products that'll be both IP66 and 67. For example, like cable glands, a lot of cable glands will be marked IP66, 67, and 68. So you'll actually see all three of those IP codes on the particular product. And part of that is because of the fact that, yeah, a project requirement may say, hey, I need IP66. And you just, again, you assume if you're a contractor or an engineer, designer selecting products for that project, and you assume that IP67 or 68 is going to be good enough. Again, I can tell you IP67 will not be, IP68 may not be.
So there is actually a question regarding how this the selection of IP are made for instrument. I guess what criteria is used to do the selection of IP. I mean, I guess the manufacturer decide what he wants to do, and then he does test accordingly, right?
Yeah, so what criteria is used to do the selection of an IP for a typical instrument and hazardous location? So generally speaking, at a very early stage, a project is going to have a project requirements, and they'll determine, the mechanical engineers, the chemical engineers, the electrical engineers will make a determination of, say, hey, we insist upon a minimum IP code of X. IP54 here, or IP65 here, IP68 here, blah, 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 blah. So there isn't necessarily one size fits all. It's usually left to the end client to make that determination, and then it's up to the subcontractors to make sure that they comply with it, or the skid package builders. So if I'm a transmitter manufacturer, obviously I want to have my transmitter have the highest rating I can possibly have, so I have one product that can be used anywhere. But generally speaking, the ones that I've seen a lot of specifications come out of the Middle East where they will require an IP55, an IP65 in many cases. I've seen a lot of project requirements where in the offshore market, they will require an IP66 or a 67. I've seen refinery applications where 65 is really the one that's called out an awful lot. Obviously, the higher the rating, there's going to be generally less selection in which you can choose from manufacturers, because not all manufacturers will have as high an IP rating. But if you can, it's a balance. You want to try to have as many options as you possibly want without necessarily just pigeonholing and saying, hey, we're going to specify a unicorn, and you just can't find it. It doesn't exist.
Can we, Bob, this is a question that I also am interested in. Can we, since NEMA and IP are not the same, right?
Right.
And we cannot really cross-reference. So if the specification requires, say, IP65, and I have rated my product for NEMA, I don't know, 4X,
right.
What do I have to do? I have to convince my customer that they are similar. I don't know.
Yeah.
To recertify.
Well, there's a couple things that you have to be aware of. For non-hazardous location equipment, generally that's not so much of an issue. Because the NEMA ratings and the IP codes, you can kind of look at the two different ones and you can say, okay, well, NEMA 4 means this, NEMA 6.5 means this, everything is A-okay. We're pretty close, right? Now, here's where it gets a little bit dicey. When we start talking about EX equipment, there's a requirement, for example, on gasketing for EX enclosures. And I've run into this quite a few times where people want to use, say, for example, a NEMA 4X enclosure for an EXE application or EXN application. The problem is that the manufacturer of the enclosure has not done an accelerated aging test, because that's not part of the NEMA testing, but it is part of the testing that's a requirement for EXE or EXN type equipment. So therefore, if you don't have that accelerated aging test, then your product is not going to meet the requirements of the EX requirements, even though from an environmental standpoint, you're going to be A-OK, but you're not going to meet the requirements of the actual EX certification. So that's where you start running into issues. It's again, it's not so much an issue with regards to general purpose equipment. It can be, don't get me wrong. Some clients will insist on, you know, hey, I need to have an IP rating on my enclosures, and I will not accept a NEMA rating, or vice versa. But when it comes to EX certification, that's where we run into issues, is things like accelerated aging test on EXE enclosures, NEMA 4X enclosures. There's also an impact resistant test under EXE that is not part of the NEMA ratings. So there are some additional testing that has to be done. In many cases, you look at enclosures and you look at a NEMA 4X box and you look at an EXE enclosure, and they look virtually identical, but there may be some differences. The wall thickness might be a little bit thicker on the EXE enclosure. Again, the accelerated aging test. There's also a temperature rise test that's done on the EXE enclosure that's not done on the NEMA 4 or 4X enclosure with terminals installed. So those are the kinds of things that, again, don't just assume that we can use a NEMA 4 or NEMA type product in an EX application. As a matter of fact, I would highly recommend against doing that. But you'll find manufacturers that will have both NEMA ratings and EX ratings on one enclosure, and that's ideal, because then you can use it both for, you know, US applications as well as international applications.
Okay, so you can see the answer, Bob. They are very well out. Everybody got his choice. T6, everyone answered everywhere. If I remember correctly, T4 was the right answer. Am I correct?
I think so, yeah. What is it, 125? So yeah, if we go back, I'll double check here just to make sure.
Okay, guys, this is the reason why we have a wall chart, right?
Yep.
So you can look
it up. Yep.
You keep it on your desk, and then you say, what is that T4? Oh, okay, I can see it here now.
Yeah, so T4 is 135 degrees C. A T3 is 200 degrees C. A T5 is 100 degrees C. So if we have a product that's marked or it's the under the maximum relevant surface temperature of that product will not exceed 125 degrees C, then that means that it will be marked as a T4. Now,
we have a lot of more slides to go, but there is a question. I don't know if you want to elaborate on this now. It was on slide 18. I skipped it earlier. It was about, can you elaborate more on MSC, explosive pressure on slide 18?
Yeah, the explosive pressure, the maximum. So what that stands for, that's the maximum experimental safe gap. That has to deal with the tolerance of a flame path. So when we have a machine surface, the manufacturer has to make sure that the machine surface or a threaded design or whatever the flame path is, that it's within certain tolerances that are spelled out specifically within the 60079-1. And the most dangerous gases will have a finer tolerance. So for example, if you look at the tolerance on enclosures, flame-proof enclosures for, say, for example, hydrogen, you will actually visually, you can actually tell that the tolerance is actually much tighter. It's difficult to tell, but that's what that has to deal with, the explosive pressures. And what we're trying to do is that we assume we're going to have an explosion on the inside of a flame-proof enclosure. Those maximum explosive safe gap, if you will, that's the tolerance in which we allow that hot flaming gas to cool off, to work its way outside of the enclosure, but not work its way outside so quickly to where it will ignite the gases surrounding the enclosure. So that's what that's all about.
Great. We were at slide 22.
Okay.
Next.
So kind of finishing up a lot of this on what you see on the slide, and this is an important one. We'll spend a little bit of time here, but there are different protection concepts, and we've spent other webinars and going through the various pros and cons of these various protection concepts. But this is kind of the basics that you really need to understand if we're in the EX world. What are my options? And it's basically broken down into 4 major concepts. And this goes back to our explosive triangle, in which we're trying to eliminate one or more legs of the triangle. So energy limitation,
I'm not sure.
that's typically intrinsic safety, right? So we're limiting the amount of energy that can be exposed into a hazardous location. So we're eliminating that leg of the triangle. Non-sparking is considered to be increased safety is an example of non-sparking. So we're eliminating any sparking that will take place on the inside of an enclosure or a light. Containment, that could be flame-proof, it could be powder-filled, it could be enclosed break. Separation, this could be things like pressurization. I've got a pressurized panel, oil immersion, restricted breathing. All of these kind of fall within the various protection concepts. And so as you read the chart, you'll see for gases, there are protection concepts that are suitable for gases and suitable for dust. So intrinsic safety is indicated by EXI. It's suitable for zone 0. The standard, the relevant standard to follow is the IEC 60079-11 or 25 if we're talking about a complete system. The maximum installation in the US is Division 1, or for US standards, we follow the FM 3610 or UL 913. And that's how you kind of read this portion of the chart. So as a design engineer, if I'm designing a flame-proof enclosure, right, I need to know the details of 60079-1. That's going to give me those things like maximum experimental safe gap, how to build it. If I'm more interested in finding a flame-proof box and utilizing it and figuring out how to install it and inspect it, then I actually follow the 60079-14 standard, which is my design standard. So these are the various protection concepts. Again, you don't necessarily have to know all the ins and outs of those 60079 standards unless you're a manufacturer building that type of equipment. And again, this is where an example, intrinsic safety is energy limitation, divided up into 3 ranges based upon the fault tolerance, EXIA, IB, or IC. There's an increased safety, non-sparking. We eliminate the potential for a spark or arc to occur due to the design of equipment. Non-sparking EXNA is now known as EXEC. It's a lesser form of E, which is now known as EXEB. So some of these markings have actually changed. Containment, flame-proof, what used to be known as EXD is now known as EXDB. Powder-filled used to be EXQ, is now EXQB. And enclosed break used to be known as EXN large C, now it's EXDC. These concepts contain the explosion and do not allow the hot flaming gas to ignite the surrounding atmosphere. And then finally, separation. So could be encapsulation, hermetically sealed, pressurization, oil immersion, or restricted breathing. There are some other protection concepts that are out there that we haven't included here. For example, there's EXOP that has to deal with optical radiation. So there are some other protection concepts that are not listed in this chart, but those are a little bit more unique. And maybe the next time GMI updates their chart, they'll want to make sure that they include that in there. So again, separation, we separate the ignition source from the explosive atmosphere using different techniques. Oops. Now, finally finishing up with a little bit of marking, and I won't spend time on the North American marking because I think the majority of our people here are probably more on the international side of things. So what you see on the left-hand side, and I'll just kind of read across the top, You'll see a CE mark that's telling you it's compliant to a European directive. The 0575, that's the notified body that's doing the surveillance, the folks that are coming in and doing the QAN or QAR on the behalf of the manufacturer. When you see that little EX in a hexagon, that's telling you it's compliant to the ATEX directive. Then you have equipment group, Roman numeral 2. And again, as we spoke about previously, anything that's above ground will be a Roman numeral 2. Anything below ground will be Roman numeral 1. Then we see a 1G, and that's equipment category 1 for a gas atmosphere. A 1G basically means that this product is suitable for zone 0. Then we see the marking string for the standard marking EXIA 2C T4 GA. So this is intrinsically safe. It is suitable for gas groups 2C, which is suitable for all gas groups. It has a T4 rating, and it also has an equipment protection level of GA. And the GA, if you will, and the 1G, the category, mean exactly the same thing. So the EPL and the equipment category mean the exact same thing. Then as you go down at the bottom, you'll see a copy of the ATEX certificate, and there's a copy of the IEC EX certificate. On the very right-hand side, the important thing you'll see is an X. The X means there is some condition for safe use that this product must be installed according to. So if I'm doing an inspection on EX equipment, or if I'm designing a system and I'm selecting a piece of equipment, and I see a piece of equipment that has an X at the end of its certificate, I want to pull that certificate and I want to look at it and find out what are those special conditions for safe use. Because in many cases, it could be something as simple as maybe I have to clamp this cable within 300 millimeters as it exits a cable gland, or it may be something to where if I'm using a transmitter with a glass lens and I want to install this in a zone 1 area, I must provide suitable protection for that glass lens, or install it in an area where it will not be subjected to impact or something like that. Those are important things to make sure that we pay attention to, because those are things that can jump up and bite your rear end at the very last of a project. And I've seen that happen many, many, many times. So we want to pay attention to that, make sure we look at these certificates. As a matter of fact, one of the things that I tell people, we supply product. We work with GMI and we work with many different manufacturers. I tell people don't ever buy a product or specify a product or do anything without pulling a copy of the certificate and reading it fully, because manufacturers will give you all this nice, beautiful, glossy brochures. They'll say their product, will do everything, but we want to make sure that the certificate doesn't have something in there that's going to jump up and really create problems. So this is the marking that you would typically find on a barrier. And I know this is probably kind of difficult to read, but I'll kind of scroll through it on at least the top line. You have an EX there. You have a Roman numeral 2. That's for surface industry. You have a 3, and then you have a 1 in parentheses. So 3 is telling us where this can be installed. This is a category 3, which means it's suitable to be installed in a zone 2. However, I have a 1 in parentheses that's telling that it's providing downstream protection out of this barrier into a zone 0. It can be installed in a gas atmosphere. The protection concept is EXNA, non-sparking. But then when I see brackets, IAGA, that's telling us again, the downstream protection from this barrier can go into a zone 0, and then it's rated for 2C, T4, GC applications. So that marking string right there is telling us what we would actually have on an intrinsically safe barrier. The intrinsically safe device that this would be hooked up to would be marked something like Roman numeral 2 with a 1 without brackets, 1G, EXIA, 2C, T4, GA. And that would be the marking on, say, for example, a transmitter or a signaling product or something that's actually being protected upstream by the use of a GMI safety barrier. So there's a marking for both the barrier itself, and then there's the marking for the device itself. If it's a simple device, say a thermocouple or something like that, or a switch, it's actually does not even require to be certified, doesn't actually have to be marked. But this is what you would typically find on an intrinsically safe barrier. So there's a lot of markings on there. You'll find your output parameters. You'll find your North American certs. You'll find copies of all the other different certs and approvals. So you want to zero in on the relevant information that's really key to what you're looking for. And this is an example of a flame-proof enclosure in which it's both ATEX and IEC-EX. And in this case, it is EXDB 2B plus H2T5. And I don't know if you can see my mouse here or not, but this is where I'm looking at. So this product is telling me it's suitable for a zone 1 because of gas atmosphere GB, EPLB. Then I've got DB as my protection concept. It's suitable for 2B gases plus H2, and it's suitable for a T5 environment. And by the way, it's suitable for a minus 20 degrees to a plus 55 degree. And here's an example. We have IP66 and 67 both, which is nice because if we have questions of whether or not this is suitable for that environment, we've got both. This is our ATEX marking string that we have up here for gases and vapors and dusts. This is our IEC-EX marking string right down here. And so we've actually got it separated. Notice the difference. We have categories. We have the EX in our hexagon. We have our CE mark. We have our notified body information here. But a lot of this information here is exactly the same as the information right here. There is no difference. Here's a copy of the certificate under ATEX. Here's the copy of the certificate under the IEC-EX.
Okay, so now we are back to the web and to the poll that we were supposed to launch earlier.
Is this the one?
Let's redo it. This is the right one, right?
I think so, yeah. So I know we're kind of running out of time. So instead of
we are running out of time, but I think we can do this, and then conclude here, with with this.
So
guys, let's see if you can. It's not easy.
Yeah.
It's numeral 2 parenthesis 1 EXDB square bracket IA numeral 2 CT6 GB GA. That's a lot of marking, Bob. I'm still, I've seen it several times, still can't get it right. And I see that you are answering back the same way you did earlier. A general mix, everybody's just guessing. That's the feeling I have. I would do exactly the same.
So a couple hints, right? So we need to know what's the protection concepts that we have here. DB, that's flame proof, right? So we can rule out D because it's not pressurized enclosure. So it's either A, B, or C. Notice that we have IA in brackets and GA in parentheses. So that's telling us a hint that this has actually got associated apparatus on the inside of a flame-proof enclosure. Associated apparatus is a fancy term for intrinsically safe barriers. So I want to look and see, is there something in there?
So I have two answers, A and D, which contain something.
Well,
no, actually, most of them, also C contains something.
It contains increased safety relays.
Okay.
There is no such animal as an increased safety relay.
Okay, so that's you.
So
that's a
due to the process of elimination, it is a flame-proof enclosure suitable for 2C gases located in a zone 1 area containing associated apparatus. So A would be the correct answer. So
and as a matter of fact, let me tell you, you've been answering at the later part, but anyhow, most of you today had
Most of
answered
you got it
A.
right. Yeah, most of you
Yeah,
got it
most of you got it right. I'm not sure you got it right because I was giving it away or not. I wasn't looking when you were typing in. But we have some live questions.
Yeah.
Maybe we can go into that in the last moment, a few minutes. Maybe you can scroll to the next, which should be our closing remark, right?
Yeah. We'll skip. We had some Q&As, but there
We can
really
skip.
wasn't
So
much.
the point is that the wall chart, you can download it. I actually have shared in one of the answer how to download it. There's a link. You can take that link.
Okay.
But basically it is in our website under download, you can find it. Then
There's also, yeah,
what's next, Bob?
Yeah, the functional safety fundamentals wall chart. There's another
Is
wall
also
chart.
there in the download. You can also download the functional safety manual and wall chart.
Yeah, and I know we kind of skipped through a lot of this stuff because we only had 45, 50 minutes to kind of go through this. So, reach out to me, or if you have some questions on anything with regards to EX after the webinar, feel free to reach out to me. I try to answer questions as much as I possibly can. But again, I would go ahead and collect them. If manufacturers and certification bodies are more than happy to get them out there, collect them. And some are better than others. Use those to kind of quiz yourself. That's what I tell students when they go through classes is that, get that wall chart. Don't just let it collect dust. Go and read it and quiz yourself. Do you understand this? If you don't understand it, then go back through some of the training materials and try to, sharpen yourself, right? Here's a key thing, right? As soon as it's published, it's out of date. So make sure that whatever chart or tool you're using is up to date and references the latest standard directives and requirements. And again, we are only as strong as the weakest link. In the EX world, I emphasize this so much. If you look at industrial accidents that take place throughout the world, sometimes it's an operational issue, sometimes it's an installation issue, but in many cases, it's also an engineering issue. And if the problem exists at the engineering level, no matter what we do at an installation level, we probably can't fix it, So it's critical that from an engineering standpoint, we start off correctly. We make sure that we understand what we're dealing with. This is a safety critical industry, and we want to make sure that, people's lives are at risk. And we want to make sure that we're doing everything we can to make sure that we are the most knowledgeable. The other thing about this in the EX world, as I mentioned, Apollo, I've been in this business for 39 years now, and I'm always learning. Don't ever let yourself become complacent.
It's a big risk, complacency.
Complacency is the worst. You don't want to be complacent. Always test yourself, always question yourself, question other people, question people that have been around for 50 years. Just because you've been around a long time doesn't mean anything, quite frankly. So
I've seen a plant that have been around for a long time, engineers running, and a lot of issues. But you mentioned about engineering, when we do our webinar on functional safety, there are studies out there that demonstrate that majority of the accidents are caused by faulty engineering. 40–50% of the accidents are caused by faulty engineering. The beginning, you set it out wrong, and there's nothing you can do later. Bob, here's our
couple questions.
There is a couple of live questions. Is there a UL certification for USA market equivalent to EX certification or NFPA?
Yeah, there is. Lorenzo, in the United States, we're governed by what is called the National Electric Code, and the NEC is the NFPA 70 document, if you will. And within the NFPA, or OSHA, Occupational Safety Health Administration, is basically defers to the National Electric Code as to what you should follow. Here's the key thing to remember. OSHA also defines who are NRTLs, nationally recognized test labs. So the way you can actually do this is that you can go to OSHA's website. It's osha.gov, but if you just do a search for OSHA NRTLs, that will bring up a list of all of the certification bodies that are approved in the United States for various products and topics. Now, you want to make sure, because they'll have a whole bunch of them, you want to make sure that you look for the ones that are certified to the relevant HAZLOC standards. That's the important thing you want to do. So there are, UL is one, CSA, FM, DECRA is now an NRTL, SGS, BASIFA. There's a whole bunch of them out there. So you do not have to go necessarily to UL. It used to be pretty much everybody would just go to UL and they would assume that that's the way we had to go. So
On the
you
other hand, Bob, customers, if you don't see
Yeah.
the logo, they give you a hard time. We have to fight that all the time.
Yeah, and then and that's a big issue. Sometimes the people just insist they want to see the UL logo, so to speak. But technically, legally, from OSHA's standpoint, and it's up to the electrical authority, the authority who has jurisdiction in that marketplace in the United States, to make a determination of whether or not they'll accept an alternative. And legally, they're supposed to not. They are allowed to accept other certification bodies, if you will, or
Which have been
NRTLs.
accredited by
Yeah.
OSHA. The one last question.
Yeah,
It's about, when we have fixed, I guess, a label onto the box and we use screws to do that. Can we violate the design? That's a good question.
yes.
I'm
Yeah,
wondering why you would apply a label though if you're not a manufacturer.
Well, I mean, it's not uncommon. A lot of manufacturers will, they'll supply a flame-proof box and you want to have a tag number, phenolic tag or something like that. Now, some manufacturers will say, yes, it's okay as long as you follow these requirements. Generally speaking, however, if the manufacturer does not give you that information, and I've seen this happen a lot on EXE enclosures, where people will drill through the enclosure, they'll put epoxy and they'll take some rivets and they'll put a phenolic tag or something like that. You have potentially violated the ingress protection rating of that enclosure. So I would not do that. I would use an adhesive type, or I would go back to the manufacturer and ask them, hey, if I have to have a mechanical fixing system, what can I do? Is there an option? So some manufacturers of, for example, flame-proof enclosures will say if you blind drill down to a certain depth with this diameter and use a drive rivet and put a phenolic nameplate on there, that's acceptable. Other manufacturers will say no. I would just be very, very careful. We don't want to go through the walls of an enclosure. That's the key thing. We really don't want to do that, because if the moment we do that, we're probably going to violate the ingress protection rating of this enclosure. And potentially, if we're doing it on a flame-proof box, we've now introduced a non-certified flame path that potentially could create a dangerous situation. So yeah, be very, very careful with regards to attaching. If you're putting, adhesive type labels, if you're doing, phenolic type labels or something like that, no problem. But the moment you start doing some drilling and modifications to it, just check with the manufacturer, find out exactly what they allow you to do. And in some cases, they'll say, yes, you can do it as long as you follow this, this, this. In some cases, the manufacturer will say, nope, can't do it. So you need to consult with the manufacturer at that.
Absolutely. I will probably not do it because, who's going to know that I consulted the manufacturer? I need some piece of paper. Bob, you've been always very thorough. Your answer are, amazing. You know it all. We've been running late. I don't want some of the people that had to go, then they show up that they didn't follow all the webinar, but although we completed the webinar. So thank you very much, Bob. I don't know why we're seeing your
Sorry.
your desktop. There's got nothing funky there. Thank you guys for being with us today. We'll see you next time. Bye-bye, Bob. Thank you.
Thank you very much.
Ciao,
Have a
ciao.
good evening. Ciao.
Ciao, ciao.